So from the notes that I have given you about parent functions and toolkit functions and all sorts of functions, you should remember that e to the x is going to be an exponential function. And my base is e, which is approximately 2.71. And so I know that there are two key points on the function e to the x. I know that e to the 0, so I would shove a 0 in for x, would give me a 1, because any number to the 0 power is 1. So I would, if I evaluated at 0 for my x, it will turn into a 1. And then also, if I evaluate at 1, it will give me e, because e to the first is 1. Okay, let's see if I can make that better. There we go. All right, so in these, how many do we have? We've got 6. So in these 6 examples, I am going to do the original function in blue, and then we're going to transform it, or translate it, or move it, or stretch it, or do something. Okay, so I'm going to do the first one first. So I know that the point 0, 1 is on my graph, and I know that the point 1 comma e, which is 2.71, is also on the graph. So looking at this, I know that I can graph that. So everything else is an estimate of the points. So like, I don't know exactly what that point is. I'm just ballparking it at this point. So what do I want to do? This says grab my function and add 2 to it. So this is going to be a vertical translation. Grab the function and add 2. So for all of my translated functions, I'm going to use pink. Okay, so if I'm at the point 0, 1 and I add 2 to it, that means I'm going to change my y value. So I'm going to go 1, 2 and add 2 to it. On this one, I'm going to go 1, 2 and I'm going to add 2 to it. So also notice, just for kicks, you've got a horizontal asymptote at y equals 0. So my horizontal asymptote is at y equals 0. Well, that asymptote moves along with it. So I'm going to move that asymptote up 2 units. So my asymptote is now at y equals 2. So my new function is the pink one. So I've got a horizontal asymptote at y equals 2, and if I had plotted multiple points, these would be identical to one another, just the pink one would be lifted up 2 units from the blue one. So I would have picked up the blue one, walked 2 steps up, and plopped it back down. All right, so I now have 10 to the x. Look, it's another exponential function. How do I know they're exponential? Because my variables are in the exponents. So I know that every exponential parent function has the point 0, 1. If I evaluate 10 raised to the 0 power, I get 1 for an answer. I also know that the point 1 comma base, well, my base is 10, is also on the graph. And I also know that there's a horizontal asymptote at y equals 0. So go back to this one for a second. If I substituted in a 1 for x, so 10 to the first, 10 to the first is 10. So my answer would be 10. So I'm going to plop these two down. Here's 0, 1. Here is 1, 10. So I've got 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's my graph. I've got a horizontal asymptote at y equals 0. So I'm going to graph this thing. Notice he goes up a whole lot sharper than this one did. Okay, so this one was more of a gradual, and this one just like, whoop, he just shoots up. Okay, so what am I going to do? I am now going to take that function and I'm going to drop it 8 units. So that includes the asymptote and that includes the points that I've graphed. So this one, I'm going to drop it 8 units. So take your function, drop it 8 units. So here's my point, 1, 2, 3, 4, 5, 6, 7, 8. And you're like, but it's not at the point 0, negative 8. No, because I didn't start at 0, 0. I started at 0, 1. So 1 minus 8 is negative 7. So I have a horizontal asymptote. Instead of y equals 0, it's going to be y equals negative 8. This point was at 10. I'm going to drop it 8 units. So 10 minus 8 is 2. So I have this point, and then I can connect those dots, points, okay? So that is what that graph would look like. So the original function is the blue one. The transformed function is the pink one, okay? So let's do it again. We're going to find basic points, and then we're going to transform them. So I have f of x is x squared. So what do I know about x squared? He's a parabola. He is a parabola. His vertex is normally at 0, 0. And then I would have the point 1, 1 and negative 1, 1. Why? Because if I shove in a 1, what is 1 squared? It's 1. So the point 0, 0 is on there. And the point 1, 1 is on there. And then I have some, and I could be a whole lot more specific. And I could plot more better points, but it's a sketch. So there we go. All right, so the blue thing is my original function. There's no asymptotes because nothing is guiding the graph or limiting where it can go. The next thing I want to do is, notice I've got a plus 5, but it's inside with the x. So what is different about this? This said, please take my function and go up 2 units. Please take my function and go down 8 units. Well, this one is different because it's inside with the x. So it's telling you to move horizontally. Okay, since it's affecting your x's. On these ones, they affected your y's. Because remember, f of x is the exact same thing as y. So this would be take all of your y's and add 2 to them. Take all of your y's and subtract 8. Okay, this says take all of your x's, but this is going to be slightly confusing. Because what did we do every time that we ended up solving for an intercept, for an x-intercept? We changed the sign. So if you're doing a left-right translation, if you're moving left or right, you're going to go opposite of what you think. So this does not say right 5. This says left 5. So I'm going to take this point and I'm going to go left 5. 1, 2, 3. Hang on, I just lost it. 1, 2, 3, 4, 5. And I'm going to grab this one. 1, 2, 3, 4, 5. Which means I can grab that one as well. And then why does this work the way it does? Because if you substitute in a negative 5 in for this function, okay, you will end up with, what is negative 5 plus 5? It's 0. So if I substitute in a negative 5, it gives me an answer of 0. So that's why you're moving left instead of right. Okay, so make sure you can plot 1 or 2, maybe 3 points. Okay, so let's do this one. I have an x to the third. So what are some key points about an x to the third? I'll have a 0, 0, and I'll have a 1, 1 on my x to the third. So here's this, and I'll also have a negative 1, negative 1. So it's going to look like this, and that should look familiar from when we did multiplicity. So when we had multiplicity of 3, it had that little hiccup. And so now we have multiplicity of 3 represented in a toolkit function. So this is a cubic function, and he has this little whoop. Okay, he's going up, and all of a sudden he has this little hiccup right here, and then he goes up again. So he's forever increasing. So what does this say? This says I'm going to grab my x's, but I'm supposed to go left 4. Okay, but what do you do with your x's? If it's inside with the x, you're going to go opposite of what you think. So I'm not going to go left 4. I'm going to go right 4. So I'm going to pick this up and I'm going to go 1, 2, 3, 4. I'm going to pick this one up and go 1, 2, 3, 4. Pick this one up and go 1, 2, 3, 4. So it looks like a straight line. Remember, it's not. It's got this little hiccup thing that's guiding. So that is your translated function 4 units to the right. So again, if I put in a positive 4, so if I evaluate my function at positive 4, what is 4 minus 4? It produces an answer of 0. So the point 40 is on your graph. And now I'm going to pause and read the instructions. All right. Okay, I didn't know if we were doing domain and range and all that kind of good stuff. Here we go. So now I have my toolkit function of the square root of x, and we're picking up the blue pen. So you should recognize your domain is restricted because you cannot have negatives underneath that radical. Otherwise, you'll go to imaginary number land, and I cannot plot imaginary numbers on a real coordinate plane. So I'm going to start with 0 and move to the right. So if I shove in a 0, the square root of 0 is 0. If I shove in a 1, the square root of 1 is 1. If I shove in a 4, the square root of 4 is 2. So I've got this point, and then if I move over to 4, I'm at a 2. So there is my function. He's only in quadrant 1, and that is what he looks like. So what am I supposed to do? This says take all of your y's and change their signs. So with a negative out front, that's going to be an x-axis reflection. So all of these positive y values, I'm going to change them into negatives. So instead of being up and to the right, it's going to go down and to the right. So at 0, 0, I'll still have that. But at 1, instead of having a positive 1, I'll have a negative 1. At 4, instead of having a positive 2, I'll have a negative 2. So this says change all the signs on your y's, because f of x is the same thing as y. So when I do that and start plotting points, I end up with a reflection across the x-axis. So if you think of the x-axis as water, this is your original function, and it's been reflected down. Okay? So this is the blue is your original. The transformed function is the pink. Okay? So let's do it again. I have a cubed root of x. I'm okay with odd roots. I am okay with odd roots. So the point 0, 0 is on there because the cubed root of 0 is 0. The point 1, 1 is on there. The point negative 1, negative 1 is on there. So I will notice that these points are on here, but since it's a root, it's going to be shooting off to the left and right. So come back over here for a second. We had, here's this. We had a cubic function, and he was more vertical. He still is moving left and right, but he's doing it slowly. He has a more vertical thing. My root is going to be wider. Okay, so he's still going up, and he's still going down, but he gets wider faster. Okay, so what am I supposed to do this? This says change all my signs on x's. Okay, well, I can't change the sign on 0, 0, so he's just 0, 0. So now it says if I change the sign on my x, what I'm going to end up doing is reflecting it across the y-axis. So if you kind of sort of imagine, turn it on your side for a second. Notice it looks like a cubic function. All right, so I would be reflecting it. This is now, I turned it on its side. So this is still my x-axis, and this is my y-axis, but I'm doing a y-axis reflection. So this is your water this time. So I would be going this direction, and that reflects this arm, okay? And I'd be going this direction, which reflects this arm. So if we turn it back this way, you'll notice that all I did was if the y-axis is my pivot point, I just flipped it. Okay, if the y-axis is your pivot point, I just flipped it. So what that means is I'm going to change the signs on my x's, and they will produce the same y's. I'll change the signs on my x's, but they will produce the same y's. Notice that there's not a negative out front. Okay, so let's see. We will say that that is a good stopping point and pick up another video.